Here we have another for what values question. For what values of h does f of x equals 0 have one positive solution to this particular function? So we draw a graph, and with the graph we also draw this particular function, and we know that that is a quadratic with a turning point at h minus 2. Of course, this graph has a turning point at h negative 2. In this case, h is 0. So we can put in the turning point h minus 2, and it might be an idea just to guide us through the translations to put in another line. And that line is y equals 2. That's just to guide us through how this graph moves or is translated. So if we move this graph along, it can't really move up and down because we know that we have a translation of minus 2, which effectively shifted a normal x squared graph down to minus 2. But it doesn't shift up and down because that's a fixed minus 2. But this h is not fixed, which means that our graph can move left and right. And what we're interested in is for what values of h does f of x equals 0 have one positive solution? Well, f of x equals 0 is just another way of saying x-intercept. If we have a look, right now we've got two positive x-intercepts. Here we've only got one. That looks like it's a positive intercept. 0 is not a positive intercept. So here we've still got 1. There it is, just 1. Here we've still got 1, still got 1, still got 1, and just there we will have no positive solutions. So really the range of values for h is between this point here of the graph and here. So really we're interested in the x-intercepts and what they are here and here. And the x-intercepts of course occur when x minus h squared minus 2 is equal to 0. So let's work that out. X minus h squared minus 2 is equal to 0. So x minus h squared equals 2. We add 2 to both sides. Take the square root of both sides. We get plus or minus root 2. And we can add h to both sides. So it's really going to be h plus root 2 and h minus root 2. So those are our two intercepts. And here they are. There's one x-intercept and there's another x-intercept. We kind of have to decide what values those x-intercepts will take so that we have one positive solution. So here's one positive solution just after h plus root 2 is greater than 0. So we want h plus root 2 to be greater than 0. Not equal to 0, but greater than 0. We want h minus root 2. If it's equal to 0, we'll still have one positive solution. So h minus root 2 can be equal to 0, or we want it to be less than 0. So here we have those conditions. H plus root 2 is greater than 0 and h minus root 2 is less than or equal to 0. We solve, we'll have h is greater than negative root 2 and h is less than or equal to root 2. And a more efficient way to write this, I suppose, is that h is between root 2 and negative root 2. And that will be our solution.